Welcome to the Getting Started with GeoStudio video series. This tutorial video introduces how to use the Slope W product of GeoStudio 2012. This tutorial video has been designed to help walk new users through the basics of setting up a simple slope stability analysis in Slope W. So, if you are new to Slope W and are not sure where to start, you have come to the right place. The main topics that will be covered in the tutorial will be how to create an analysis in Slope W by using the Define view to set up the analysis, the Solve Manager to solve the numerical analysis, and the options available in Results view to gain a deeper understanding of the analysis. So, let's get started. Here you can see some results of a stability analysis that was conducted in Slope W. Here, Slope W was used to determine the minimum factor of safety and the critical slip surface for the profile shown. The pore water pressure contours and defined piezometric line are also shown. We will start on the GeoStudio Start page, where you can create a new project, open an existing project, or click on the appropriate links to view examples, tutorial videos, or engineering books for each GeoStudio product on our website. We will create a new project and choose to create the project using the default International System of Units. If preferred, a blank document can be created with imperial units at this point. Once our new project is created, the Key in Analyses window is opened, where we can add a title to our analyses tree, add an author, or add comments for future users. Now we are ready to add the Slope W analysis to our analysis tree. We will add a limit equilibrium analysis. Here we can change the name of our analysis, as well as change our analysis type if desired, but we will keep the default Morgenstern Price analysis type. We can also add a description about the analysis to help future users. We will make sure that the half sine function is selected for the side function and that the pore water pressure conditions are taken from a piezometric line. Next, we will look at the Slip Surface tab, where we will select the Entry and Exit Slip Surface option in the left to right direction. The Factor of Safety Distribution tab allows the user to define probabilistic or sensitivity parameters, but for this tutorial we will simply keep the constant option on. Lastly, the Advanced tab can be checked to see what extra options might be available for the analysis. In this case, the geometry settings will have a minimum slip surface depth of 0.1 meters with 30 slices. The Factor of Safety convergence settings are set to a maximum number of 100 with a tolerable factor of safety difference of 0.001. You can use the zoom options along the bottom bar of your screen or under Set Zoom to change the view of your analysis, either to the extents of your domain or the extents of the work area page, or simply zoom in or zoom out. We will simply zoom into our drawing page as we don't have our domain defined yet, and then take a look at the drawing scale of our analysis. We will go to Set, Units and Scale, and here we can see the units that are being used in our current analysis. Here is where we can change our units if desired, but we will keep the default of kilonewtons. The problem extents boxes can be used to help modify the scale of the analysis. Changing these values can change the view of your analysis so that the entire domain remains on a single page. We will toggle off the Calculate Max Extents option and change our minimum x and y coordinates to -4 meters and our maximum x coordinate to 50 meters and our maximum y coordinate to 40 meters. This automatically adjusts our scale values to accommodate these extents. We will toggle on the Calculate Max Extents again and fine-tune our horizontal and vertical scale values to ensure a 1-to-1 aspect ratio. As you can see in the background of the page on my screen, there is a grid already activated. You can go to Set Grid to turn this grid off or on, activate Snap to Grid, or change the grid spacing. Now we are ready to create our domain. We will start by adding axes to our working area to help visualize the drawing extents of our domain. This is completed by going to Sketch, Axes. Here you can also change the names of the axis titles as well as the X and Y axis extents. We will set the X-axis extent to 40 meters and the Y-axis extent to 15 meters. You can also change the increment size of the axes labels by toggling off the Auto Increment Size button and changing the increment size for each axis. For this analysis, I will simply leave the Auto Increment Size for this axis on. The approach to use when developing a numerical model is to determine the geometry, assign materials, draw pore water pressure conditions, and draw slip surface geometry, which will control the mode of failure you are going to analyze. Let's start by creating a domain. Here we have a sketch of our problem where 2 layers of a slope exist. I will go to Draw Regions and draw my 2 soil regions following the sketch of my slope. Here, points will automatically be made wherever I use the left mouse button to click on the working area. Once the first region is created, I can draw a second region. Then I can use the right mouse button or the Escape button on my keyboard to stop the Draw Regions command. Points and lines can also be added to the domain if required, but for this example, only the 2 regions we created are needed. Next, we will add the materials to our analysis. I will go to Key In, Materials, to open the Materials Define window. I will add a new material, give my material a name, and enter my soil properties for the Moore-Coulomb material model. I will only add material parameters to the Basic and Suction tabs, and I will not change the remaining tabs from their default settings. Next, we will add a second material for the lower soil layer. There are 2 options that can be used when adding the second material. The first is to simply use the Add button again to create a new material, or the Clone button can be used to clone the first material. Then I will adjust the soil properties to represent the second layer. Now that my two materials are defined, I will go to Draw Materials and add the materials to each region representing the soil layers. The next step will be to define the piezometric line, which will define the pore water pressure conditions for both of the soil layers during the stability analysis. I will go to Key in Pore Water Pressure. Now we can simply add the piezometric line by adding X and Y coordinates. The line will appear along the domain while the points are being added. We can see that the piezometric line goes through the slope with a reservoir of water present above the toe of the slope. The other option would have been to draw the piezometric line by going to Draw Pore Water Pressure. Here you could add the line using the mouse and then check if you want the piezometric line to influence the pore water pressure conditions in both of the soil layers or only one. In this example, both of the soil layers will be influenced by the drawn piezometric line. Note, since we are modeling a partially submerged slope, the weight of the water will automatically be included in the analysis. The blue shaded zone has water force arrows, which shows that the resulting water force will be applied normal to the ground surface line. Earlier, we selected the entry and exit method to control the location of the trial slip surfaces. So now we will choose Draw Slip Surfaces and use the cursor to define zones where the slip surface will enter and then exit the ground surface line. You can see where your ground surface line begins and ends by the green triangles on either side of the domain. When using the cursor to choose the entry and exit zones, you must click and hold down the mouse button, only releasing the mouse button once the zone has been drawn. Now the problem definition has been completed. There are a few methods that can be used to check that the input parameters are being recognized correctly by the software. First, you could use the Draw Contours option to see what soil properties are attributed to each of the soil layers. These contours can be modified in the Draw Contours command, where you can change the coloring scheme, add a legend, change the increments of the contour values, or add new properties to view. Since we have added a piezometric line to define our pore water pressure conditions, we can view the pore water pressure contours of the domain. Notice that when you define a piezometric line in slope W, the software considers the pore water pressures to be hydrostatic both below and above the piezometric line. You can also label the contours. You can use the Modify Objects command to move your legend into a better view of your domain. You can also use the Preferences toolbar along the right side of your working window to change what is being visualized on the domain. For example, you can go back to seeing the material colors for each region, add region labels, remove contour lines, remove or add the piezometric line drawing, and so forth. The viewing preferences can also be changed in the View Preferences window, including other options such as font size of the region labels. Now, we will make sure that the analysis is activated in the Solve Manager window and solve the analysis by clicking on the Start button. Once solved, the window will automatically change to the Results view instead of the Define view. By default, the critical slip surface is shown, with the factor of safety result for that slip surface. Currently, we can also see the pore water pressure contours with the labels that we painted on the domain in the Define view. Again, we can turn on the pore water pressure contours by clicking on the Contour option in our Preferences toolbar. Other contours can also be drawn using the drop-down menu or edited using the Draw Contours button as was completed in the defined view. The Slip Surfaces window allows the user to view other slip surfaces that were analyzed in the simulation. To return to the critical slip surface, we can simply click on the Select Critical button. The graph button can also be used to see the factor of safety versus lambda graph for both the moment and force factors of safety. The factor of safety for that slip surface is chosen where it satisfies both the moment and force equilibrium. Other slip surface plots can be seen by simply clicking the slip surface number in the Slip Surfaces window while the graph window is open. It can be helpful to look at how parameters vary across the slip surface. For example, graphs can be added to plot material properties or other result information for the chosen slip surface. Here, we can plot the slice data of the current slip surface and choose the pore water pressure versus slice number. This plot shows the resulting pore water pressure values for each of the slices within that slip surface. I can also use the More button to copy the graph image so that it can be pasted as a picture into another program, the graph data as tab delimited columns which can be pasted into another software like Microsoft Excel, or exported as a separate comma delimited file. I can change the visualization of my graph by clicking on More Options. Here I can customize the labels on my graph, change the scale of my axes, rotate my graph, add or remove a legend, change the style of my lines, or change the font of the text on my graph. You can also view the individual slice information for the slip surface being viewed in the results window. You can simply click on the slices to view the force information on each slice, or cycle through the slices using the arrow buttons. The slice information can be copied and pasted directly into a report or spreadsheet. There are also other options that can be used to view result information within the results window. For example, you can view object information, which outlines information for each geometry item, such as the material properties assigned to a region. The View Report button can be used to develop a report of the input data and will open the report in an HTML format. This gives you all of the information regarding the input data, geometry, and other information from the analysis. By default, only the location of the critical slip surface is shown in the results view. You can, however, choose to view the location of other slip surfaces by going to View, Preferences. Here, you can activate the Multiple Slip Surfaces option and choose to increase the number of viewed slip surfaces to 10. Now, the slip surfaces for the 10 lowest factors of safety are drawn on the profile. Sometimes it is helpful to think in terms of a failure zone as opposed to a specific slip surface location. A safety map can be drawn on the profile to indicate a zone where slip surfaces with very similar factors of safety could develop. Note, if at any time you are unsure in your understanding of the dialog boxes, you can simply click on the question mark in the top right corner of the dialog box, use the Help tab, or use F1 on your keyboard to access the online help. If at any time you would like to view the engineering book for the product you are using and do not want to return to the GeoStudio Start page, you can simply click on the Home button on the online help. We have now reached the end of this introductory tutorial. Note that not all of the powerful features of Slope W 2012 have been used or discussed here. Further information on each command can be found in the online help, supporting documentation for Slope W, as well as in other tutorial videos of the Getting Started with GeoStudio video series. Thank you for watching.